Hello, and thanks for joining us here at this virtual RSA conference. Myself and Jason Lam will be talking today about, attack and defend, protecting modern distributed application and components. Now, Jason Lam, he is a certified instructor for the SANS Institute. I'm myself, Johannes Ulrich. I'm the Dean of Research for the SANS Technology Institute, our graduate school. And the two of us together are teaching a defending web application class. And in this class, in the last couple of years, when we updated it, we added more and more sort of cloud components and modern applications like this. And while we did this, we came sort of across a couple of patterns that we saw that we would like to share here in this presentation. And part of this is, of course, microservices and APIs. A modern web application is really sort of a single page application that pulls in a multitude of components. So we'll talk about some of the authentication challenges here, but also the integrity challenges. How do we preserve the integrity of these remote components? In the end, of course, we don't like to leave you hanging with just problems. We'll also sort of give you some solutions. Actually, the way we set up the talk is that Jason will sort of protect the attacker's perspective, while I'm presenting the defender's perspective. So with that, Jason, why don't you walk us through that little architecture that we set up here for this presentation?
Sure thing, Johannes. Thank you for that. And hi, everyone. Today, our application, the subject that we're going to talk about today looks like what you have on the screen. And what we have particularly is a modern day web application. And what does that mean is that we have a static file storage component that actually store, for example, the images, the JavaScript that you're going to load. And then subsequently, once the JavaScript hit the browser then calls out through API to integrate the data back into the page. And that API call is going through the API gateway, as it normally does these days. With the API gateway behind it, there are other API backends as well. So the API gateway also acts as a traffic cop and also a security device in some cases to make sure that the bad guys don't get in. In addition, we also have an IAM component. That's where the users go and authenticate and get authorization to access certain information within the application. So that's really the background of the application that we're going to look into today. With that, Johannes, why don't you walk us through the application? How does it actually look like? How does it work?
Yeah, so this is a little application that we have here. Again, sort of a very simple single-page application to demonstrate this architecture. When I'm logging in here, I am actually then being redirected to our gateway, our authentication gateway. Let me just reload the page here and click on that. So SANS and then my complex password. That sends me back now with the authentication information to this application, and I can look up the service ticket here. So this is the simple application we built. Of course, there is some API in the background. We just saw Keycloak. That's what we're using here for our IAM. We also have Kong, another open source product that we're using for our API gateway. With that, Jason, tell us a little bit about how you would attack this application.
Sure. Today, we've got 3 different attack scenarios. Let's talk about scenario number 1. I call that a microservice exposure. And let's see how we expose things. So before the microservices age, our request looks something similar to what you see on the screen. So we've got a giant request, and then there are different data set that get assembled together to hit the website with something like a session cookie to identify yourself when you go back to the website. That's how it started, right? And then in the modern day application, next slide, what we have looks like this. The request looks like you still call the application, you still send a post to the web application, but now instead of like the regular session and so on, you send this thing, the authorization token. Mark this chunk of text there, right? Like make a mental note of it. Later on, this chunk of text is going to benefit us from an attacker standpoint hugely. Okay, so that's the subject of our discussion later on. Next, before we pivot over to the demo, what we're trying to achieve here in this attack scenario is there's the API gateway in the middle. What can we do and how do we actually use some of those credentials that we have used, that we've seen earlier, to actually sort of bypass the API gateway and hit the back-end API services? That's kind of what we're going to do here, okay? With that, let's get over to the demo and we'll show you some of these attack scenarios. Now, with that, the first thing that I want to highlight is that we just pop up the developer tools in the browser. Any modern day browser will have the developer tools. And this is really meant for debugging and also help us identify what goes on in the background. With that, we want to show the request that we sent earlier. So we can go to the network tab on the developer tools. Yes, we can generate the traffic and go to the network tabs. And you can see that just now that request actually generated this 1, 2, 3, 4 request to the website. And if we click on that request, it will show you the additional details related to the request. You can see quite a bit of details there, but I want to highlight the bottom part to you, which is the request headers. So along with that request, there was a token that was sent forth to the web applications. And that token is exactly what the subject of our next part is going to be, the attack scenario. So what we're going to do is we're going to copy this whole request. So the nice browser these days allow you to copy the entire request as if it is a curl. What is curl? Curl is a command line tool to generate requests so that you can manipulate it as much as you want. And we just copy that. And we can, before we actually go and do anything, let's also talk about what we can do to actually identify targets to actually attack. So far we've copied that request, but where are we going to drop it, right? So if we go back to the browser for a second, when we want to identify targets, right? Like, okay, so we said we would bypass, but where do we land? In determining what targets we can go and drop this credential and say, hey, service me, please, we can go and take a look at the certificates. So modern day web applications, obviously you have HTTPS, the SSL, the TLS portion of it, and it requires you to have a certificate. If we look at a certificate here, it has multiple names. These may be names that are other components of your web application that accept that token. So maybe you can just directly talk to it using the credentials that you have already authenticated yourself with and ask for service, okay? So that's one way. And the other way that you can also do this particular portion is also going to the certificate search. Essentially, all certificate authority nowadays publish the logs of all the certificate registration, and they let you search it. Organizations like Google gather together and let you search it. So right now, what we're doing is that we show you related to this domain. These are the certificate, or these are the host names that have certificates. These are the juicy high-level target that we can attack. Now, armed with that information, we can potentially go off to our attack. And there are other things that you can also attack as well, right? Like you can also target, you can also do port scans to identify other ports that are on the same host that are serving web content, or other hosts on the same subnet, the network IP address range. Now, those could be targets as well. So for the purpose of this, let's simulate that we have another port listening. That is the target backend API for us. Now, earlier we copied that curl command. That's what this is, right? You see a lot of text here, but what it is that the browser is telling you, hey, if you use this Chrome command, then you generate this exact same request that I sent to the website earlier. So over here, the highlight of that is the top part, which is, the URL. We're sending the data, we're sending the request over there, okay? And let's send it now. Like 8443 is where we're sending it, the port. So we got our response back, okay? The response comes back. You can see, those of you who know HTTP protocol, this is HTTP 1.1 200, okay? And I also want to highlight the last line of the header, which is Vir Kong. Kong is our API gateway, as Johannes mentioned earlier. Okay, so this particular request was serviced by the API gateway, and then the last portion of it is the data portion, which we saw earlier in the web application. Now that's how it goes. What if we change it to another port and drop it to our target? Okay, our target in this case, our simulation here is the backend is actually running on 443. Let's send it. Now, this one is a little bit different. Now, you already noticed that the header comes back a little bit different. What difference is there? Do you notice a Vir header? I don't. It's because we send it directly, bypassing the gateway directly to the API backend. That's what we have done here. And the backend service answered it, and without any crying, any complaints, it just came back with the same data. Notice that the end results, the bottom part is really the same. The message is the same. Now, I just bypass the API gateway. You may say, hey, what's the big deal? I'll let Johannes talk about what it means from a defense standpoint. What have I just, broke on his application? Johannes?
Yeah, so let me show you Kong, the API gateway that we're using here, and the administrative interface for Kong. Let me pull this up here to show a little bit what sort of security features we do have available here. Now, first of all, authentication is still done by our API. So we didn't bypass authentication, but Kong offers a number of features. Like here, we just have a couple enabled. Bot detection, which is very simple. It sort of looks for user agent strings. We also have rate limiting, and the rate limiting I have currently turned on. So I can show that to you quickly. If I'm going back to sending these requests to port 843, and let me send them a little bit faster. And what you'll see here is eventually I'll get this error message of 429 too many requests. And API rate limit exceeded. And you see, it didn't really take me much. I didn't really set up a very large rate limit here. If I'm going back directly to the API, then of course I can send these requests as far as I want. And I'm sending them here as fast as I can with my keyboard. It may scroll a little bit too fast for you as you're streaming this, but I never get any of these rate limit messages. So this is one thing we are bypassing here by bypassing the API gateway. We are bypassing any kind of filtering that may happen in the API gateway. And in some cases, we may even have some authentication in the API gateway. Now, how do we defend against this? And I promised I will tell you how to defend against some of these issues. And of course, traditionally, in our good old on-premise world, we would have had a network perimeter. And yes, you can set some sort of IP-based access rules in the cloud as well. But what if that service was implemented using serverless? Then this may not work that well anymore. Well, luckily, the cloud people have thought about this, and they gave us a tool to address this problem. And it is done via these policies that we can find, private endpoint policies. So this is a private endpoint policy, just a very quick sample to kind of show you what they're all about. This one does restrict access to an S3 bucket. And notice that, well, here in this policy, we don't have credentials. You still need credentials in order to access this if it's configured appropriately. But what it really is all about is this condition here and this source VPC in this example, we limit requests to originate here from a particular source VPC that we identify in this policy. So that's really the trick here. We're not specifying the IP address, we're specifying the actual source, which actually is better in some ways because IP addresses change. So with this, we really sort of more identify. It's really more about identity of the source of the request. It's not so much about a random IP address that we may not be able to enforce to be consistent in our application. So this is one thing we can do. So we can block access, direct access to the API. We can restrict access that bypasses our API gateway and enforce that all requests originate from the API gateway. But earlier, Jason pointed out this blob, and that's really what the authentication is all about, this bearer token, or as we're using in this case, JSON Web Token or JWT. Who is better to tell you about JSON Web Tokens than Jason? So Jason, tell me about what they're all about and how you would attack them.
Thanks, Johannes, on that one. Love the Jason reference. Let Jason tell you how to attack these things. Okay, so we're going to quickly walk through what we're looking at first. Earlier, that chunk of text that we were looking at, right, like that big token, it actually means something. And if you throw it into certain website like this jwt.io, it actually tells you or decipher it for you so that you know what's contained inside. And later on, we'll demo it to you to see how that works. Basically, it means something that you and I can both look at and open it up and understand what it means. So that's one thing. And then the JWT token, the job token actually contains certain payload, right? As I said, it means something. So what does it actually contain? It actually contains the claims for the user. So it basically identifies who the user is, what the user can do, and such information. So it can be fairly sensitive as to the access that you're going to be granted to the application. Armed with that information, let's look at our target state and our demo that are upcoming. So what we have here is that, again, the same application being attacked, but this one is a little bit different, right? We're not just bypassing just like what we did before, but let's see what web application can expose for you to do versus what you can actually do. Because usually when you go and take a look at the developer tools and so on, you can see that the web application does certain functions and so on, but you may or may not know, okay, so what else can we access? So in this example, we'll show you that if you're not configuring things right, how do you actually extend beyond normally what you can use towards the application, right? Like you can stretch your credential to do extra things. And let's pivot over to the demo mode. Okay, so earlier, remember that I was talking about the application, which is we're showing here. We have captured the curl command, the token, and so on. Okay, so that's what we're going to start off with, right? First of all, let's clear up the screen. Let's show that one more time that the backend is actually working. Let's do that one time. Okay, so it seems that this is working. Okay. What we want to do is capturing that token and then throw it into the website that I was talking about, jwt.io, and we're gonna paste that into this website. Okay. Go and try this website out. It's pretty cool, right? So this website allows you to decode that token, and you can read what's inside that token. So the first part of it talks about the hashing algorithm. What is the hashing for? The hashing is really to protect this entire token. Because again, this token, remember, the attacker, me, get access to it. So I can potentially just fuss around with the content of it, add additional scope that may not be there, can grant myself extra access. How do the defender protect it? They put a hash on it to guarantee that it has not been altered. So that's the algorithm that we're talking about there. And within the payload portion, you can see if we scroll down, you can see information such as when was this token generated, when does it expire, what URL generated it, and more importantly, right, if we look further down, you see the ROM access, the rows, and also further down, you got like the account rows as well. So those two things basically talk about what access you have and what function you can access and what rows your user identity can do and so on. So these are very, very sensitive information. And look at the name of those rows that you have, like COVID vaccine formula, offline access, UMA authorization, take over the world. Wow, that's amazing. So these are the access that are granted. That those functions may or may not be accessible normally with the web application interface. Now, with that, so we can go back to our demo there, right? I'm with that information, knowing the token, knowing the content of the token, that helps us a lot with the attack, right? So I propose where we do one thing, right? Instead of calling the API ticket and so on, let's just shake hands with the API. Let's call the API directly, okay? We're gonna call it directly. And yep, let's hit enter there. Now, we're not calling a specific operation function, but we're handshaking with the API and saying, hey, API, how are you doing? And the API tells us immediately that, hey, you can hit me this way, meaning you can call this particular operation called COVID formula, take over the world. Wow. Remember that it corresponds to the row that we have earlier. So it looks like this is something that we can definitely call and invoke the service. Now, let's go and try this take over the world thing, right? Because, hey, I would love to take over the world, don't you, right? Let's try that. Let's call that and see if we have the permission to actually invoke that service. Again, from the front end of the web application, there may not be a call directly to it, but if we call it this way, directly, we're hinted by the token, it does give us some data, right? So it indicates that, the response here, it does indicate that, yep, the cat's planning to take over the world and so on. Yes, it successfully got invoked. And basically what it means is that normally in the web user interface, you may not be able to get to this particular function, but now gathering all the data, acquiring by the token, acquiring by the AP, calling the API directly, we're able to gather the information on how to directly access some of these functions that may not be apparent. And with that, hey, Johannes, I think I just, hit some of the functions that you did not mean to be exposed publicly.
Yeah, so let's talk about how to defend against this. This vulnerability reminds me a little bit of sort of a traditional web application where you do have an administrative feature that doesn't do proper access control, kind of these direct URL vulnerabilities, as they're sometimes called. And an attacker, well, usually doesn't see it because they don't have the right button in their user interface if they log in as a normal user. But there's something else that we sort of did different in traditional web applications. In traditional web applications, we had a session token. And the session token itself didn't really have any value per se. It was a random string, and then it was presented to the application. The application had some kind of backend storage that then told us what this session was allowed to do. What's different here with these JSON web tokens is that this information resides on the user. And while it's properly digitally signed and cannot be altered, so it's not one of these admin equals yes cookies, the attacker has more insight into the application. And there are two ways how we can sort of protect ourselves here. One is sometimes referred as a phantom token. So in this case, we sort of move back to that more traditional web application stance. What we do here is the user is logging into our IAM service, and then the IAM service is returning a ticket. This ticket is only used to present to the API gateway. The API gateway will then exchange the ticket for the actual token that we had before and use that to gain access. So this isolates the user from that back-end ticket. Problem here is, well, we have additional HTTP round trips between the gateway and the service whenever we're hitting the gateway. Solution, well, let's cache the information at the gateway. But we're playing a little bit of trick here. So what do we use to actually index, look up that cache, and what we're using as an index kind of to search it? When I'm now logging in to the service, instead of returning that token to me, it just returns the signature. And the signature, well, is as unique as the token. So at the same time, the service is also storing the ticket with the gateway. And the client is now presenting that signature. The signature is used to look up the right ticket and is being used to authenticate the operation back to our API. So this is a bit more efficient. It saves us that round trip to the IAM service here. But so Jason, I got the authentication under control, it looks like. We foiled the cat's secret plan to take over the world. What else could happen with cloud components? And I think they're going to talk a little bit now about that static part we sort of ignored so far. So Jason, up to you.
Yep. Thanks, Johannes. That was good that you could defend that application. But I've got one more trick under my sleeve. Let's try that, right? This one I call remote bouncer. Let's move on to, let's look at this request. What is in this request? So in our architecture here, you can see that in this architecture, we have the static file portion, which actually links to some HTML and so on. That HTML nowadays with modern day application, you don't just have HTML. Like who does that, right? Nowadays, you gotta have some JavaScript that links to something useful, right? Whether we run React, Angular, any of the slightly older things that are more common like jQuery libraries and so on. Modern day applications generally load like 15 to 20 different JavaScripts very easily. And most of them often from different sources as well, right? For example, if you load Angular, you're likely going to use the Google's copy. You're going to link it with Google, and Google is hosting it for you. That's generally how it goes. With this is what it is showing here, right? The HTML has a script reference. This one is to payment.com. And essentially, when the users come and load your HTML, it knows the browser goes over to payment.com to load that JavaScript and it'll run that JavaScript. So if the JavaScript, anytime you run something, that can be a little scary, right? So that's really the background there. And then a little more about the scripting itself in the next slide. So on the scripting itself, okay, and on the right-hand side, you can see, right? Like, some of you may tell me, hey, this JavaScript is a script, we can recognize it, look at it, right? Modern day JavaScript, either minified or compressed and so on, it's very difficult to read. Like even if I give it to you, you wouldn't make too much sense out of it, right? So how do we protect these resources and how do we attack these resources is really the question here in this scenario. Now, let's look at the next scenarios so that we can talk about how we're going to attack the slide. So, okay. In this one, we're showing you the developer tools and showing you that jQuery is being loaded, right? Like under the cursor right now, we're loading jQuery from this generic cdn.com, okay? And what it is here is that, this HTML page is loading a script from a foreign location that is not part of this sec5todo.com website, okay? So what we can do is you can assume that I somehow is able to attack this particular CDN and compromises it and control everything over there. All the content over there is under my control. I'm going to replace that jQuery script with an Evo script that I own, okay, that I just wrote. And let's replace it, please. And we will also show you the page that loaded as well. Okay. And by the way, that script that I loaded, that Evo script that is there, is really meant to capture keystroke. Okay. And that's what we're trying to do there. Okay. So let me flip it back to the original format of what we need to show you here. That's the script that we're including here. Good. Okay. And let's check this out. So we're going to reload it multiple times. Okay, so we change a script. The browser normally caches those scripts, so we got to reload it, hot reload it, and make sure that the browser is picking up the new script. And with this new script, I think we just loaded it here. With the new Evo script that I loaded, okay? So it's still loading that script and so on. That's good. Now, you can see that there, right? Like hint on the screen earlier. What we have in the script is that there's a keylogger component, and Johannes already typed in some keystroke over there. Look here, the keystroke is captured, and if you roam over the mouse cursor on that, the keystroke actually go to a domain called evoexample.com as well. So it's not going back to the same website. It goes to a website that I, the attacker, own. That's my website. Okay, so I'm capturing all of Johannes's and his users' keystroke, because whenever the user go to that page, then their keystroke are captured by me. Okay, so that is something that I can do to your website, Johannes. What are you?
So let's defend against this. Now, what we need to do is we need to tell the browser what JavaScript is legitimate for our site. There's a neat feature that we can use called sub-resource integrity, or an SRI hash. So if I'm going here to the original jQuery, and I'm just copying that, and I'm pasting this in the site here, it will now create a script tag for us that does include this integrity hash. So let me copy this, and if you paid attention, I actually had to fix this earlier quickly because we already had this from prior testing in that page. But when I'm opening my page here, and I'm now inserting this new version with the integrity hash. Let me remove the .original part. So we actually load the evil JavaScript that's still there. So you kind of see how this prevents us loading the evil JavaScript. Okay, let me go back here, and then you already see, actually, as I flipped over here, it tried to reload it, and it now gives me the error that it failed because, well, it wasn't able to verify that hash. Also, my JavaScript, of course, now broken on the page, as it should, because, well, we can no longer load jQuery here. So only after I'm actually now switching back to the original jQuery, only after I do this, and if I now reload again, now everything is good, and my application should work again. Oops. Still have it not quite right here. Probably forgot the right to reload again. But now the JavaScript is loaded again, and everything is good. But with this resource integrity hash, we are actually able to tell the browser that this particular JavaScript got changed. And that's really sort of what this is all about. So we are validating these remote resources using the hash. And with that, an attacker, MageCard, for example, they made a lot of money with this type of attack, is no longer able to just swap out some remote resources that we don't really have any control over. So, Jason, you just want to wrap it up here?
Sure thing, Johannes. That was good defense on your part. Like now that you locked down the hash for us, I don't know what to do. So that basically is all my tricks for today. And well, the lessons learned here, particularly for this presentation, and hopefully you enjoyed it, is that there are a few key learning objective here. First thing, I would recommend that people review your modern day application architecture. There are a lot of really good libraries, really good framework out there that you could create your applications with. However, if there's still a lot of pitfalls and so on that you can fall into. So review it, make sure you understand the configuration of your components. As Johannes pointed out earlier, right? Some of the cloud component may not have all the configuration right to say, okay, this is the origin of the location. Only if data comes from that, then is mine, right? So you would want to review that and also understand the credential flow. Those particular token, the bearer token and so on, it means something, right? And you would want to be very careful about how you handle it, where it goes, and whether it include extra details that you don't need. And those are some of the key things that you would want to look at very quickly. Now, in the longer term, we recommend people to review the credential handling guidelines for the development teams so that they're not inventing the wheel or reinventing the wheel at every single application. Make it consistent, make it secure, and that will take some time to develop. But once you develop it, then you can reuse that pattern on an ongoing basis. And this will be a trick to survive, the journey and a battle with the microservices API-based web applications. So hopefully you enjoyed this presentation. Thank you very much for attending this.
Yeah, and looking forward for your questions. So please let us know if you have any questions, and thanks for watching this presentation.